Here is the introduction to logarithms. First of all, do you know what is logarithms and how it is useful? You see here, if I have given the equation 10 power x is equal to 100 and if you are asked to find the value of x, then how do you proceed? Here, if I have given 10 power x is equal to 100 and if you are asked to find the value of x, then you can write this 100 as 10 square. Then if 10 power x is equal to 10 square means bases are equal. If bases are equal, you can equate the exponents so that x is equal to 2, you may say. Similarly, if I have given 2 power y is equal to 8 and if you are asked to find the value of y, then how do you proceed? Then you may write this 8 as 2 into 2 into 2, that is 2 cube. 2 power y is equal to 2 cube. Here bases are equal so that you can equate the exponents and you may write y is equal to 3. You can solve these two equations by writing both the RHS to the same base of LHS. But if the questions are like this, for example, if 10 power z is equal to 2, then can you find the value of z by using this knowledge? Here, in order to find out the value of z when 10 power z is equal to 2, you have to write the value of 2 to the base of 10. But 10 power 0, 10 power 1, 10 power 2, 10 cube, 10 power 4 and no value is equal to 2. Therefore, you cannot write 2 to the base of 10. So that you cannot find the value of z by using the above knowledge. Similarly, if you look at the second example, 2 power a is equal to 5. Then can you find the value of a by the previous knowledge? If 2 power a is equal to 5, in order to find out the value of a, you have to write the 5 to the base 2. Means 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5 and no value of 2 power 1, 2 power 2, 2 power 3 is equal to 5. Therefore, you cannot find the value of a using our previous knowledge. In these above cases, in order to solve these type of equations, we need the knowledge of logarithms. Now let us know the definition of the logarithms first of all. If a power x is equal to n, and then we can write x is equal to log n to the base a. Logarithms in shortcut, you may write this as log, L-O-Z, log. Log n to the base a. You should read this as x is equal to log n to the base a. Logarithm of n to the base a. In shortcut, you can write it as log n to the base a. Here the condition is a should be greater than 0, means base should be greater than 0 and a is not equal to 1 and n is greater than 0 and both a and n should be real numbers. I shall repeat the definition. If a power x is equal to n, then you can write x is equal to log n to the base a, where a is greater than 0 and a is not equal to 1 and n is greater than 0 and both a and n should be real numbers. In this case only, you see here a power x is equal to n. This is an equation in exponential form. And whereas x is equal to log n to the base a, it is in another equation. This equation is in logarithmic form, you can say. Here a power x is equal to n is called an equation in exponential form and x is equal to log n to the base a is called an equation in logarithmic form. Therefore, a power x is equal to n can be written as x is equal to log n to the base a. Now let us see one or two examples. For example, if 10 power z is equal to 2, that is what we thought of previously. 10 power z is equal to 2. If 10 power z is equal to 2, you could not find the value of z using our previous knowledge. But by using logarithms, if 10 power z is equal to 2 is the given equation, then you can say that the value of z is equal to log 2 to the base 10. You see here, if a power x is equal to n means 10 power z is equal to 2. Our given equation 10 power z is equal to 2 is in the form of a power x is equal to n, where a is equal to 10, x is equal to z and n is equal to 2. If the given equation is in the form of a power x is equal to n, then you can find the value of x as log n to the base a. Therefore, here also the value of z is equal to log 2 to the base 10. Here, if 10 power z is equal to 2, then from the definition of the logarithms, you can find the value of z as log 2 to the base 10. As there is a value for log 2, so that you can find the value of z. There are logarithmic tables, and using the logarithmic tables, you can find the value of z. And look at the second example. The second example we thought of previously is 2 power a is equal to 5. If 2 power a is equal to 5, then you could not find the value of a using our previous knowledge. But here, from the definition of logarithms, you can write the value of a as log 5 to the base 2. Again, you can find the value of log 5 to the base 2 from logarithmic tables, and those tables are developed by John Napier. You can find the value of log 5 to the base 2 from the logarithmic tables. Now the next concept is I have to change the exponential form to logarithmic form and vice versa, that is logarithmic form to exponential form. Let us convert the given equations into logarithmic form to exponential form and exponential form to logarithmic form. Let us know one or two examples. Here from the definition we know that if a power x is equal to n, then log n to the base a is equal to x. Here if a power x is equal to n, then log n to the base a is equal to x. Here if you observe both, then how do you remember this? Here the base is a. In exponential form a power x is equal to n. Here the base is a. Here also the base is same a. Therefore, if a power x is equal to n, this is the exponential form. If you are asked to write this exponential form into logarithmic form, then you can write the same equation as log n to the base a is equal to x. Or you can change the logarithmic form to exponential form also. That is, if log n to the base a is equal to x, then you can write the same equation in exponential form as a power x is equal to n. For example, you see here, if 10 square is equal to 100, 10 square is equal to 100. This is in the exponential form. Now let us convert this into logarithmic form. If you write it in logarithmic form, then 10 square into 100 may become log 100 to the base 10 is equal to 2. The value of log 100 to the base 10 is equal to 2. This is how we have to convert the exponential form equation into a logarithmic form. Let us see another example. If log 8 to the base 2 is equal to 3, this equation is in logarithmic form. And let us convert into exponential form as the base is 2. Therefore, 2 cube is equal to 8. This is the equation in exponential form. You may repeat the same video if you have any doubts, so that you can understand the uses of logarithms, you can know the definition, and you may understand how to convert exponential form into logarithmic form and vice versa. Now let us know some laws of logarithms here. The first law is log xy to the base a is equal to log x to the base a plus log y to the base a. For example, if I have given log 15, then this 15 can be written as 3 times of 5, that is 3 into 5. Log 3 into 5, this is in the same model, log x into y, which is equal to log 3 plus log 5. Similarly, another example, log 2 plus log 3 plus log 5. Here, this is in expanded form. Now, if you simplify this, then you can write the same as log of, since plus is there, you have to multiply 2 into 3 into 5. 2 into 3 is 6, 6 into 5 is 30. Therefore, in simplified form, log 2 plus log 3 plus log 5 is equal to log 30. In both the examples, we used the same law, which is log xy to the base a is equal to log x to the base a plus log y to the base a. And second law of logarithms is log x divided by y is equal to log x to the base a minus log y to the base a. Here is an example, log 3 by 2. 3 divided by 2 means it is log 3 minus log 2. It is an expanded form. Similarly, another example, log 100 minus log 50. If you are asked to simplify this, then you can write the same as log of 100 by 50. Why? Since this is in the form of log x minus log y. Log x minus log y is equal to log x divided by y. That is log 100 divided by 50, which is equal to log 2. Since 50 in 100 2 times. Now look at third law. Log a power n is equal to n log a. For example, log 25. You can write 25 as 5 square. Here this exponent may come as quotient, that is 2 into log 5. Therefore log 25 is nothing but 2 into log 5 by using the third law. Log a power n is equal to n log a. Another example, 4 log 3. If we are asked to take this 4 inside, then log 3 power 4. 3 power 4 means 3 into 3 into 3 into 3, which is equal to log 81. And the fourth law of logarithms, log a to the base a is 1. Log a to the base a is equal to 1. For example, you see here, 2 log 3 to the base 9. How can we simplify this? Here if you apply the third law first of all, this is in the form of n log a. Therefore take this 2 inside. So that this is log 3 square to the base 9. What is 3 square? 3 square is 9. Therefore log 9 to the base 9. Now if you apply the fourth law now, log a to the base a is 1. Therefore log 9 to the base 9 is 1. And another example, log 0.001 to the base 10. You can write this 0.001 as log 10 power minus 3 to the base 10. 10 power minus 3 is nothing but minus 3 log 10 to the base 10, and Hughes simplified value is minus 3. Here it is not mentioned there, but you may please note down that log 10 power minus 3 to the base 10 is minus 3 log 10 to the base 10, which is equal to minus 3. You can complete this. And fifth law, a power log n to the base a is equal to n. A power log n to the base a is equal to n. Here is an example. A power log 3 to the base a, whose value is 3. If you find any type of such equations, you can use all these laws of logarithms so that you can simplify the given equations in logarithms.